Okay, guys, welcome back to the Boosedy Business and Statistical Academy. Okay, so today I'm going to go through some kind of a question related to calculus with analytic geometry. Then we've been doing this series for a long period of time, and then previously I was yesterday and day before yesterday I just did some kind of two videos on how to find the volume of a bead using in one video shell method, the other one washer method. Okay, let's look at that today's problem. Okay, let's go straight to the problem and try to get this done. Okay, this is the question. I'm going to use Q, fancy Q. I hope you can see. I want to make sure everything's clear. Okay. Q, my question would be evaluate the integral, this one, I integral stands by the I cortex times ln within argument you have a sin x dx. See, it's the question. I want to make sure you see that one. Some places are not clear, no? Make sure that everything's clear. Yeah, I think now they can see. Okay, that's okay. I think it's in a good shape right now. Okay, I'm trying to get this done using like a three methods. Three methods, okay? Method one, three methods. Let's say method one, using a certain formula. Using a formula, man, what that would be? Using a formula. What kind of formula? What's the formula that's gonna go with this one? We can get this done using a formula. Yeah, it's in good shape. I think you guys can see everything clearly. I don't want to make sure that, because earlier we had like a too much light. I just control the lights and then just put aside some lights. So now you can see the board clearly, because I want to make sure you guys see the contents on the board rather than having too much light on the shining on the board. Yeah, I think it's clear cut now. Or that you can see me clearly. Doesn't matter whether you see me clearly or not. It's not that much important. I want to make sure you see the board. Okay, then what would be the formula gonna go with something like this? You know that we have a formula like this. We know that we have a formula for I, this one, you have a gx to the power of n, g of x or f of x, doesn't matter, okay? If you're not interested in g, you can put the f of x, okay? Excuse me. For my convenience, I put the g, okay? And if you have its derivative right next to this one, see? Then your answer is one shot gx to the power of whatever the power you have been increased by 1 on that particular function, composite function, see? This is a composite function, see? This is a composite function also, see? Divided by n plus 1 plus c, see? That's the formula, that formula. If that's the case, or in another way, I'm going to write the same thing in another way, okay, here, for your convenience, okay? Another way of writing the integral formula. Another way of writing, let's say I integral u to the n, you have its prime here, okay, with respect to x, then your answer should be u to the n plus 1 over n plus 1 plus c. See, that's another way of writing, but if you want, you can write like that way. But make sure u is a function of x, where u is a function. I'm going to write function with this abbreviation down the road. X. You can see clear. Okay. Either that formula or this formula, okay? So I'm gonna erase this one and erase this one too, and see which one we're gonna pick from here. As I'm trying to use this formula. So okay, who will be taken as gx and what is my n? See? So if you look at these two functions, see, there are two functions here, one here, one here. Then you might be thinking, am I going to go ahead and get this done using integration by parts? That's another way of doing that one, but we're not going to go there because we are trying to use the formula in the first place. In that scenario, you have to figure out only one thing. There's a g of x and n. Which one would be gx? If this is g of x, once you integrate, once you derive this one, would that produce this answer? I don't think so. What's the derivative of cot x? Minus cosecant squared x. So it won't. But let's go the other way around. Let's look like a g of x, okay? If you take the derivative of this one, it should be what? 1 over sine x. Sine x should be derived again, and in this chain rule, then you're going to get a cos x. Cos x divided by sine x would give you cot x. Looks like you're going to get this one. Okay? So I'm going to say, I'm planning to use this formula in this form, okay? In this format, sorry, in this format. So I'm going to say let my gx would be nothing but ln sine x. And take the derivative of this one and see. take the derivative of this one and see. Should be 1 over sine x. See, with respect to sine x, you take the derivative of ln, which is 1 over sine x, then you take the derivative of that guy times cos x. See, then you're gonna end up with cos x over sine x, which is cot x. Pretty much fitting into what we have. That means this guy's derivative is this one. See, I'm going to indicate like that. See, that means this is your gx. See, this is your g prime x. Gx has been written to the power of n. N would be 1. See, n is 1. N is 1. See, n is 1. Therefore, according to the formula, you can easily say what? Whatever you consider as gx, see, this is your g of x. See, this is g prime x. See, whatever you see, this is nothing but gx to the power of n plus 1 over n plus 1 plus c. So you know your gx is nothing but ln sine x to the power of, in the beginning, your n is how much? See, your n. See, it should be in that format. See, this is gx. Gx, but it's in gx to the power of n format. See, n is what? 1. You're going to add another one. Then 1 plus 1 plus c. See? I'm going to delete this one. Press this one, then you can see clear. See? That means your answer is, without doing anything, ln x to the sine x whole thing to the power of 2 plus c. That's your. In this case, that you have to make sure that which ones you can take as a gx, and then whether its derivative would be, then power should be there something, whole thing. I'm talking about the whole thing, okay? Whole thing has been raised to the power of 1. N is 1. Here n equals 1, see? Equals 1. This guy's derivative right next to this one, we saw that. So if that's the case, with the aid of the formula, you can easily write the answer. Okay, that's method 1. Let's go to method 2. In method 2, you can use the u substitution. Okay, you can use the u substitution how many times? Just once. See, let's use u. Method 2. Using u substitution, say this one, later on subs, like that, my abbreviation down the road, substitution. Method 1. See, you had this integral, I integral cot x ln sine x. Doesn't matter, your u or gx gonna appear here or here, doesn't matter. Okay, you know that. You have a 2, see, functions. Which ones you're gonna take as u for sure? You can remember last time even for this guy being taken as u. See, let u equals what? The whole thing. You can consider whole thing, ln sine x whole thing. in that u substitution, what are you going to do? Instead of working with x, you are planning to work with u. If that's the case, you have to make sure you're going to change not only x terms, you have to change even the everything. Everything in x has to be replaced with u, especially the operator. See, this is the operator in x. This x operator has to be written in terms of u. Therefore, you have to build up what? The operator. That means you're going to take the derivative with respect to u on this side, which is 1, and you write the operator. And on this side, you take the derivative with respect to x, and you write the operator. See, with respect to x, sine x, from the chain rule, you get cos x. See, from here to here, chain rule. You did this one earlier. Chain rule. See, you don't stop there. You keep going, and dx. Excuse me. Then this means du equals cos x over sine x dx, and du equals cot x dx. Therefore, dx is nothing but du over cot x. Or you can simply say this whole thing, cot x dx, can be easily replaced by that whole thing. Doesn't matter, you get the dx. Okay, or this whole thing, see, cot x dx. Okay. Doesn't matter. Then we're gonna plug into this one. See, I don't do anything for the cot x because they get cancelled off. Ln sine x means what? This term is u. Dx means du over cot x. See, they get cancelled off. They get cancelled off. So you're going to end up with a very basic integral in terms of u. See, in terms of u. So now you integrate with respect to u. U squared over 2 plus c. Now you can replace u with whatever you assume as u in the beginning. Therefore, I equals half u means ln sine x whole thing squared plus c. See, that's the same answer. That's the same answer. This symbol means therefore. See, 3 dots at the vertices of a equal triangle. See, we got the same answer. See, we can say replace. Now, replace u with down the road I can write like this, with u with this one, u equals what? Ln sine x. See, that's what I did. That's the second method. Still you're gonna get the same answer. Okay. Okay, let's go to the third method. Third method, kind of you are using by accident, okay? By accident, you're not gonna take the u as ln sine x. Sometimes you might be thinking why we cannot get it like sine x only. Go inside and take that one. That's the third method. In the third method, pretty much what I'm gonna do, I'm gonna use this one, method 3. Using use substitution twice, 2 times. Let's say that you have an integral, this integral, ln cot x, ln sine x dx. By accident, you're gonna think this part should be taken as u, okay? Let u equals sine x. That means you are planning to get started from there and then thinking, okay, it might gonna work. Let's see. Take the derivative, that means du, okay? You don't need the 1 anymore. Sine x become cos x and put the operator. See? So therefore, see, like that, okay? We keep like that, and from this one, therefore, du is nothing but du over cos x. See? Dx nothing but du over cos x. Let's plug in that one into this one, okay? Integral cot x, I'm not gonna do anything for this one for time being. Ln sine x means u, du means, dx means du over cos x. See? Looks like they don't get cancelled off. I'm gonna split this one. This means cos x over sine x times ln u, because I'm trying to get all the terms in terms of u, du over cos x. See, this one get cancelled off. This sine x can be replaced with u. See, then you're gonna end up with what? U 1 over u ln u du. See, 1 over u ln u du. See, this is your I. This is your I. Now we're not done yet. Now again, since that we are planning to use another substitution twice, I'm gonna say the ln u is v, or you can use from there, you can split this one into 2 parts. I'm here, okay? I'm here. I'm gonna here. I'm gonna write ln u first for my convenience, then 1 over u du, okay? From here again, if you want, you can go to the method 1, look at method 1 and get this done, or using u substitution again, subst again. You can get this done in 2 ways. From here. Can you remember in the first one, you check whether this whole thing's derivative gonna be here. What's the derivative of ln u? It's 1u, it's already there. If that's the case, this is your gx. See, gx should be raised to the power of, this means a derivative, okay, derivative, see, ln u derivative is 1 over u, it's already there. This is like my gx, gx already we have 1, you can add another one, divide by 2, 1 plus 1 plus c. So there's nothing but ln u the second plus c, and you can easily replace u with sine x. Sine x. That's one way of doing that one. Then you're going to end up with that answer again. See, replace u with sine x. Replaced u with sine x. That's what I assume in the beginning. O, you can think about O is I, this ln u is 1 over u du. You're going to think about the second substitution, another substitution. See, let v equals ln u. Then you're going to take the derivative on both sides. With respect to v on this side, with respect to u on this side, 1 over u du. But you have to make sure you put the operator. Then du is nothing but u dv. Because you have to replace du and write everything in terms of v. Therefore, du u dv. This is u, okay? This is u. Sorry, this one u times dv. Let's plug in this one here. ln u means v. 1 over u I'm going to keep as it is. Or 1 over u whole thing is dv. See? 1 over u times du means u dv. U dv. So they get cancelled off. You're going to end up with v dv. V dv. If you integrate, you get v squared over 2 plus c. See, very easy. V squared. Now you can replace v first. See, replace. This is I, this is I. Now you can say replace v with ln u. Then you get I 1/2 ln u whole thing squared plus c. Then replace, then replace u with, we can use the short abbreviation, with ln u. This one with sine x. Then you're going to have I is nothing but half ln sine x whole thing squared plus c. See, you're going to end up with the same answer. See, that's the third method. See, in 3 methods you can get this done easily. See? Okay, let's see. By accident, you might be thinking of using integration by parts. Let's see, we can go in that route too. Okay. Then method 4. Let's see if we can get this done using fourth method, integration by parts, using integration by parts method. Integration by parts. So we have this one, see, cortex, we have ln sin x, we have dx. Let's see which one we're going to utilize as, see, you know the integration by part formula. Formula says what? If you have a u, sorry, integration by parts, like a product, okay, u dv, uv minus v du. See, you have a u times, sorry, this u, dv, then your answer become uv minus v du. Let's say that which one we're going to take as u from these two. The one with the function that is that becomes very simpler than the original one once you take the derivative. The function whose first derivative is simpler than the original function should be taken as u, or something you can easily that differentiate. Look at both of these two. They both looks like a differentiable. They both functions are differentiable. But if you pick this one, which one's gonna do the integral? One should be integrated, one should be differentiated. Once you differentiate this one, this become what? 1 over sin x over sin x, 1 over sin x times cos x, which is cot x, eventually become cot x. This one, cot x, if you take the derivative, what do you get? Negative cosecant squared x. On the other hand, if you take the integral on this one, how to take the integral on cot x? Can you remember? I'm going to talk about that one separately here. Note, think about this guy, cot x dx. See, you can think about this one, split cos x over sin x dx. If you have something like that, you know we have a formula even for this one. What's the formula says here? Formula says if you have a g of x, see, the formula say you have a gx here, its derivative on the top. You don't have a power here. Power has to be 1, okay? dx, then you get ln gx plus c. See? If that's the case, you know this guy's derivative is cos x. That means, therefore, your this one should be what? ln sin x plus c. See, it can be integrated. It can be integrated. Okay. So I'm showing that when you integrate that, you get that. When you differentiate, you get that to fit into this formula. But this is some kind of supplementary discussion over here because how to get the integral of cot x. So see, with the aid of this formula. See, you don't have to do use substitution or anything or struggle like that. That we can go in that 3 routes the way that we did for the previous example. It's the same example like earlier, but see, another formula. Okay, therefore, what I'm gonna do, I'm gonna try to set up everything to use the integration by parts formula. Okay, integration by parts formula. So I'm gonna say let u would be ln sine x, dv would be my cot x dx. Cot x dx. That's how I did. Or the way that we had earlier, if you wanna write like that, you see, ln sine x, cot x dx. See, this part is u, this whole thing is dv. That's what I did. From this one, you need to get du, therefore you differentiate. Differentiate both sides. Then you get this one, du. On this side, you get 1 sine x times cos x dx, which is cot x dx. You know that. From this one, you should integrate to get v. That means once you integrate this side, you get v. Once you integrate, that means I'm writing this one, okay? This is what I meant. See, that's what I meant. You integrate. Then where's this one? Gonna keep the formula. You can plug it into the formula later. Cot x, you know this one is nothing but ln sine x. Oops, sorry. This become v. Once you take the integral, once you integrate 1, this is 1, okay, here we have 1, become v, this become ln sine x. Let's use this formula. Therefore, from u dv equals u v minus v du formula. Let's say what's going to happen. U means nothing but ln sine x times dv. dv means cot x dx. Okay. uv. U. See. U is ln sine x, okay, times du. Yes, du. Du means cot x dx. See, cot x dx. Okay. This is I'm trying to show you something, okay? So this is, I plug in here, this one, I plug in for this one, okay? Then you get this one. Then I have a u, sorry, v here. There's a mistake over here. We have a u, which is ln sine x. Then v, again, ln sine x, see, v minus, okay, minus integral v ln sine x, see, sine x du means what? Cot x dx. Cot x dx. Look at what happened. This is integral, okay. Sorry. See, I just plug in into the formula. Look at what happened. You get trying to integrate, you're going to end up with an integrate. But that integral is same as this previous integral. What you're going to do, you're going to bring this whole thing to this side. Forget about this I, okay? Forget about the I. You're going to bring whatever the integral on the other side, they both look the same. See, you can combine. You see, you don't integrate anything. You don't integrate. This is what we are trying to integrate. Then you can end up with the same thing to be integrated again. This part you're going to get to the left-hand side. So I'm going to write this one very clearly. ln sine x cot x dx plus, when you take this to this side, become plus integral ln sine x cot x dx. On the right hand side, I have ln sine x being repeated twice, so squared. See, so squared. Look at what happened. Then you combine these two and say you have a two of them. You have a two of them. See, you have a two of them. Two integral ln sine x cot x dx. On this side, you didn't integrate anything. See, you just set it up. You integrated only one time using the integration by parts formula. This is nothing but I. See, 2y. Then I, which is integral ln sine x. See, or you can simply say, you don't have to write this, I ln sine x squared divided by 2 plus c. That's it, see. Those are the techniques. See. Now you saw we got this done using 4 methods. Four methods. Okay. So until we're gonna meet you in another this kind of a very interesting, very fancy question, I'm gonna let you guys go and enjoy this video, and then thank you very much. You have a wonderful day. Stay safe, be well. Take care, bye-bye. Thank you.